Hello and welcome to this SunCAE tutorial. Today we're going to solve a heat conduction problem. We're going to use a simple square beam. Now we have to choose heat transfer and then heat conduction. Cool. First thing we're going to do is add a boundary condition and set temperature equal to 0 here, and then add another one, temperature equal to 1 here. We can check this is the case. Cool. Solve. Okay, we have this nice linear rainbow. Let's go back and replace the red BC with a prescribed heat flux, let's say 10 to minus 3. The profile is the same, but now the temperature is higher. Another problem. This little beam is 10 millimeters long in the X direction. Let me put back a temperature here. Let's put it back equal to 100. Now let's change the conductivity. It used to be 1. Let me write 1 plus X. So the conductivity increases along the actual coordinate. Now the rainbow is hotter. If we go back and write 11 minus X, it is colder. Another problem. Let me delete this boundary condition and add this face to the purple one. So 0 and 0. Now, let's put back conductivity equal 1 and let's add power, say 10 to minus 2. Now, the center is hot, up to 124. What if the conductivity depended on temperature? Okay, let's say it increases with temperature, like linearly, 1 plus T. And now we're solving a nonlinear problem under the hood. So the center is still hot, but up to 15, not 124. This is not physically real, but you get the point, don't you? Finally, let's go back. Conductivity 1 again, and now the power is a sign of X. We have stripes, but these stripes don't look good, do they? This is because the mesh is pretty coarse. So let's go back to the first step and let's change the element size. So instead of 1, let's pick 0.2, and also let's choose algorithm number 8 in Gmesh, which gives this nice text. And now the stripes are nicer. That was it. Let me know in the comments if you have questions or something you'd like me to discuss in other videos. Thanks for watching.